Hello, grade 12s. The exams are just around the corner. I'm here to assist you with a revision before the exams. In today's video, we'll be looking at a revision of vertical projectile motion. So we'll look at this question here. It's an exam guide. It's a question that tests at an exam level. So this question is question 1 here. Right, so looking at this question here, the first thing that we do every time we solve questions is that we follow a problem solving strategy, which we call the academic constitution. So this strategy has a set of rules that says I can, right? That says I can. The I in this rule, the first rule is the I, which stands for problem interpretation, and the C stands for problem classification, and the A stands for problem answer, and the N stands for the problem navigation. Right, those are the rules that we'll be following when we solve this problem. I'll start by interpreting this problem. To be able to interpret the problem, the first thing that we do is to read the problem statement so that we can interpret the problem. So the problem reads as follows. A ball is projected vertically upwards with an initial velocity of VI is equals to 30 meters per second from the top of a building. Ignore air friction and take the ground as the reference point. The first thing that I'll do with this question is to choose direction. Is actually to choose direction. I'll come here and say we're doing question 1. Then I'll say take upwards as positive. Right, now I come to this problem and we interpret this problem. So the word reference point means the origin. It means the origin. That means the ground. Here on the ground, that's where we start measuring our position, right? So this means the ground here is 0, 0, right? Is 0 meters in terms of measuring our position. So this means our ball starts at a position here of 54.08 meters, right? So our initial position here is this number, 54.08 meters. And this ball has an initial velocity, they've told us here, of 30 meters per second. Now, both this position of 0.8 meters and the initial velocity of 30 meters per second are positive because they are the vectors that are going upwards, right? Then they say to us that ignore the effect of air friction. You must remember this when you go to your exams, that when they say ignore the effects of air friction, what they mean is that the acceleration due to gravity is equals to 9.8 meters per second. Let me create space here so that I can write this properly. This means the acceleration due to gravity is 9.8 meters per second squared, right? But also it's very important to notice that this will be negative, because remember that the acceleration is a vector that always goes vertically downwards like that, right? And I've chosen up as positive, so this would be negative 9.8 meters per second. Now this problem, obviously, when I classify this, so I'm done with problem interpretation. When I classify this problem, classification involves linking this to the theory or the concepts and the formulas that we know. When I classify this problem, I can see that it's a problem that uses vertical projectile motion. So this means I'll use my 4 equations of motion, right? we can also classify this problem as a problem that uses the principles of energy, work, energy, and power, right? So this means I can use, in this case, the law of conservation of mechanical energy to solve this problem, because there is no air resistance, so the mechanical energy will be conserved, right? So those are the two options that I have. So that is part of problem classification. Once you have interpreted and classified your problem, you are now ready to answer the problem. We can go now into our questions and answer the problem. The first question says to us 1.1. It says to us, define the term projectile, right? Projectile is any object that moves in the air under the influence of the gravitational force alone, right? That's how you'll simply answer that question. Then we'll quickly run to question 1.2. It says here, calculate the maximum position of the ball above the ground. So this is very important, above the ground. We're calculating the maximum position above the ground. So what are we looking for here? We are saying in this problem that, remember, when they say above the ground, it means we're measuring from here, right? Now we're saying if we measure from here and we go to a maximum position, remember this ball will move like that, right, reaching this maximum position here. So they're looking for this maximum position, meaning here we are looking for y final, right? That is the maximum position we are looking for. We are looking for y final, right? To say what is the maximum position that you occupy. This position is measured from the ground up until to where the ball will hit the maximum position, right? We also know that at the maximum position here, our final velocity will be 0 meters per second, because the ball will stop for an instant before it returns to the ground, before it goes down, right? So one of the equations that come to mind quickly is the equation that says the final velocity squared is equals to the initial velocity squared plus twice the acceleration due to gravity times the displacement. Now in this equation, we know that the displacement is given by y final minus y initial, right? That is the displacement. That's how we define the displacement. That's how we define the displacement here. Is the final position minus the initial position. Now, at this stage, this becomes a substitution problem. We said at the maximum height, we're going to have 0 squared, which is our velocity here at the maximum height, is equals to the initial velocity of 30 meters per second squared, right? This is the initial velocity that the ball leaves the rooftop, and we're adding here 2 times negative 9.8, and we also multiplying this by y final is what we're looking for, right? And we say that the ball started at an initial position. We talked about this when we started this question, to say it started at the initial position of 58. Remember, this is 0, then it started here at 54.08. Now this means here I'll have 54.08, right? So now here we just going to use our calculator and say 30 squared. That will give me 0 this side, and I'll have 900 plus 2 times 9.8. This will give me, actually this whole thing here will then be a negative, right? Because this positive and this negative will turn into a negative 19.6, and here I'll have not v but y, the final position which we're trying to look at, the final maximum position there. It's 54.08. now this means I'll take the 900 to this side, so that I have negative 900 is equals to negative 19.6, y that minus y final minus 54.08. Then I'll divide both sides here by the 19.6, and the 19.6 also here, it's a negative. And this would then make this 19 and this 19 to cancel. Then I'll have y final. Let me go back to a blue pen. I'll have y final is equals to, so it's y final minus 54.08 is equals to, so here we're going to have the 900 divided by 19.6. Notice that the negative signs cancel each other, so I have 45.92. now I'll take this guy and bring him to this side, so that now I have y final, I have y final is equals to 45.92 plus the 54.08, and my final position will then be a positive answer that says 45.92 plus 54.08, and that gives me the final position of 100 meters. Because this answer is positive, it means this is going upwards. It means this ball is at the maximum position, right? That is going upwards, and this makes sense when we navigate this problem. So now, after we find our answer, we navigate the problem. We do this part here, the n, navigate the problem. Navigating the problem means making sure that our answer makes sense, right? So this answer here, if you check it, I'm actually adding 45, which is the height from here to here, to the, I'm adding that to the 54, right? So it makes sense that we get 100, or a number that is close to 100, and we expect this answer to go upwards. So that's how we navigate the answer, and try to be in a position where we see if our answer makes sense. So that's how you'll find the maximum position above the ground. The question 1.22 says calculate the displacement of the ball relative to the ground after 7 seconds. So after 7 seconds. Now I'll use this equation that says the displacement is equals to the initial velocity, because I have, then they've just given me time, plus half the acceleration due to gravity times time squared, right? So this would mean now that my initial velocity is 30, and here I have 7 plus 1 over 2, negative 9.8 times 7 all squared. Now this is just now a matter of putting this into the calculator. 0.5 times negative 9.2 times 7 squared, right? So this gives me negative 30.1 meters. Now, if I get a negative answer, it means this object is being displaced in the negative direction. It's going downwards, right? It's going downwards. Now let's try to navigate this problem. and see if it makes sense. Remember, always when we get out to our final answer, we navigate, we see if it makes sense. Does it relate to the problem that we're dealing with? When we look at this problem, the physical problem that we have here, does it make sense? Now, if you check here, we're saying that after 7 seconds, the ball will move up and come down again, right? After 7 seconds, we're saying it will be on its way down. It will be somewhere here on its way down, right? It will have covered 30.01 meters per second, right? That makes sense because 7 seconds is quite a lot of time. And in fact, if you go and check the time that it takes for the ball to come here, it's about 3 seconds. So it means to come back here is another 3 seconds, because we know that the time it takes to go up is the same as the time it takes to go down. So you add a little bit of 4 seconds here, the ball will be somewhere here, right? So it makes sense that the ball, it is at a displacement which is somewhere here. So the ball will be displaced from this position to that position, and this would be around about 30.1 meters at that point there. It's going down, it's on its way downwards. Now I'll jump to question 1.2.3. They say here, will any of the answers in question 1.2.1 and 1.2.2 change if the height of the building is increased? Choose from yes or no, right? And you give a reason for your answer. Now this question, there's a video that I've put on the YouTube. I think it's the second video on my YouTube channel where I actually explain the academic constitution in full, where I explain this academic constitution. This type of a question here, it's part of navigation, where we change some of the parameters in our problem to see how our answers change. If our answers do not change the way it is expected, then we know that our answer is wrong. So navigation is a way to see if there's any errors in your problem, right? So when they ask you this question, basically the examiner is trying to appeal to you to say, look at your answers that you got here and see if they make sense, right? That's the whole point why they ask you these questions, right? So now, if we look at this problem, we're saying here that the building has been increased, right? So the building here gets taller. It's now increased. It's now increased. That means this height here will be much bigger, right? So you can see that if you go back and do the calculations here, the 54 here would have been increased. It will go higher. And remember, we were adding this number here, the height of the building, right, to the maximum height, or to the height that this ball would move, to the height that the ball will move up to here, the 45.92. So now you can see that now, our final answer here, the final maximum position, would be larger, right, because we would have a bigger number here, right? And this will also change how the ball will move from here and coming back here, right, after 7 seconds, right? So this is the situation here, the question 1.2.2, where we were given 7 seconds, right? So you would see that also that will change, right? So the answer would be yes. If you increase the height of the building, right, the answer will change in those two questions. So the answer here is yes, right? The reason why it will change is because we can see from the above equations in question 1.2.1 and 1.2.2 that the maximum position, right, the maximum position and the displacement are dependent on the height of the building. they depend on the height of the building, those two. For us to get this answer, we have to have the height of the building. And obviously, as I just explained on this diagram, now even this one, for it to come back here, if the building is taller, we won't get the same answer that we got here. We won't get the same answer that we got there. So that's how you'll go about answering that question. The last question says to us, 1.3, that when the ball returns to the rooftop, a feather is projected vertically downwards with a velocity of 30 meters per second. Now this ball, when it comes back, it will go up and come back here. When it's here, immediately when it's here, right, they also drop a feather. So let me use an eraser actually to be able to draw this situation now, right? To be able to draw this situation. We're saying here now, when the ball gets here, when it has moved up and come here, immediately it reaches this point, we then release a feather, right? We don't release per se, because remember, when you release something, it will have zero velocity. So we actually throw this feather with a velocity of 30 meters per second. So this means it will be a negative velocity, because remember, we chose up as positive, right? Now they say here, which object will reach the ground first. They give you options here. They say only choose the ball, feather, or both of them. So we have three options here. Which one between these two object, the feather and the ball, will reach the ground first? Now let's go through these questions very carefully, and this is a very important question because it summarizes already what you know in terms of projectile, and it will assist you to step into the exam right ready. Right now, what's happening here is that, remember that projectile motion is symmetrical, right? Meaning the velocity that it takes for the ball to go up is the same velocity that it will come down with. So this means that if the ball went up with an initial velocity of 30 meters per second, when it returns here, it will have the same negative velocity. It will have the same magnetic velocity that of 30 meters per second, but that points in the opposite direction. And also, now we can then compare these two motions. So the ball and the feather both have the same initial velocity, and from here going down, both these two objects cover the same displacement of 54.08 meters, and they also have the same acceleration. Both of these objects, they move down with an acceleration of g is equals to 9.8 meters per second, because remember, we are ignoring air resistance here. It's more like they're moving in a vacuum. There's no air, right? And obviously, if you do your calculations here, we can see already from the information that I've put on these two objects that because we have the same initial velocity, we cover the same height, we have the same acceleration. If we were to calculate the time it takes for these two balls to hit the ground, to get to the ground, we will find that it is the same in both situations, because they have the same initial velocity, same acceleration, they cover the same height. So this means that both these two objects will hit the ground at the same time. So my option will be both at the same time, right? So they say give a reason for your answer, right? I mean, already in my explanation I've given the reason, right? But you can put it in this way. You can say both objects have the same motion. Both objects have the same motion. Both objects have the same motion. They have the same velocity, they cover the same height, they move at the same rate, meaning the acceleration due to gravity. So they'll take the same time to hit the ground. And not only that, they will also hit the ground with the same final velocity here. Right, so that's how you answer that question. Grade 12s, I hope this answer becomes a good revision for your exams, right? Guys, if you want to have more questions on vertical projectile motion, right, the exam guides, please comment VPN in the comment sections and then I will send you a copy of the exam guides where you will have a number of questions that involve vertical projectile motion for you to practice before your exams.